everyone, I'm Sarah Parker, and today I'm sharing my work on a machine learning project for our machine learning class 5440. This assignment asked us to classify the language of a five-letter word across English and German, and we were also asked to pick a third language as well, and I chose French. So normally language identification with machine learning is done with longer texts, but classifying a single word in isolation with only 5 characters is actually much tougher technically. It's kind of like a minimal data problem that tests how well different models can find the linguistic patterns in just pure raw character codes. So for this project, I compared 3 classifiers: the K nearest neighbors, KNN, the SVM, and the MLP, a multi-layer perceptron. Each word was transformed into a 5-element vector using Unicode code points. And one of the very first hurdles that I hit was that German characters were not encoded using UTF, and so this would always throw an error and cause the program to stop. So I needed to add Latin into my encodings, and you can see right here UTF-8 was used, and this was fine for English and French, but with the German characters it just didn't like it. So I added Latin, and that allowed me to effectively decode all of the words from these files for English, French, and German. Another major factor was class imbalance, and the reason for that is because the data set, as you can see once it was downloaded, is primarily over 50% English words, especially once you filter that down for 5-letter words, which we were asked to do. You can see that there's 11,000 English words, while there's only 3,000 German words and 6,000 French words. So this skewed our results towards English anyway, which we'll talk about in the results. So the first thing we did was pre-process the data, converting the words to numeric features using Python's ORD. And this essentially transfers it into that Unicode number. And then that allowed us to compare the number features numerically. So all of the words were converted to the numeric features using ORD, and then they were also labeled 0 for English, 1 for German, and 2 for French. So that's our output. It would determine, based off the input and our features, what was going to be our output. So we did a training and testing split of 80-20. So we took 80% of our words and used that for training, and then we tested it off the remaining 20%. And we also did a random state of 42 to make sure that the words were randomly selected and not just picked from the beginning of the word set. But we also seeded that to 42 to make sure that it was reproducible every time that the code ran. It was running the same random samples. So when we look at the results, at first glance, well, the accuracy for the KNN was 69%. The accuracy for the SVM was 71%, and the accuracy for the MLP was 70%. I'm going to hop over to my report so you can see the visualization a little bit clearer. So they're all very comparable, within 2 percentage points of each other, but SVM did come out slightly higher. However, this was actually a little bit misleading because it was weighed so heavily towards English. And when you look at the breakdown, you can see that SVM thought 99% of the words were English. And so it skewed those results towards English anyway. But when you look at the language of French, it was only 34% accurate, which is actually really bad. So if you kind of look at the overall numbers, I would actually recommend the KNN for this particular assignment because it was more evenly distributed. So French was much higher at 52% versus 34%, while English was a little bit less at 84%. But this is still pretty accurate. I did try several different ways to order the characters to see if we could improve these numbers by adding additional features, looking at some different um, kind of alpha alphabetical like consistencies between the language, but it actually made the models worse. And I think this just kind of goes to show that if you sometimes with adding more dimensions, it just makes your data sparse, and so it's harder for the models to learn. So in this case, actually just keeping it simple to the ORD gave me the better results. Um, I would say that my technical contribution for this project was just identifying that the overall accuracy can be a misleading metric. And that's just because of our imbalanced data set that was pulling heavily towards English anyway. But also demonstrating that the simpler feature sets using Unicode points actually outperformed my more complex attempts at making the models a little bit more improved. And so that is the overall results. And this just kind of breaks it down by language a little bit more so that you can see English, German, and French. The KNN was a little bit more balanced, where the SVM was really heavily skewed towards English, and that really failed French and German overall. So I hope this was interesting, and I found it a really technical but fascinating project to see how the models performed when looking at 5-letter words from different languages. Thank you.